Hello, today we are going to work through an introduction to derivatives and the power rule. Okay, so you may be wondering, what is a derivative? So, let's draw a y-axis, and then let's draw an x-axis. Okay. Now, let's draw some points along it. Let me switch it to a different color. So, okay, I actually don't have to. So, here, let's take a function. Let's make it, I don't think I do that too well. Let's make it, let's make it y is equal to x squared. That's our function. Okay, so now this is not very well drawn, but we have y is equal to x to the second power. Okay, so what a derivative can do is it can get you the slope along any point of the line. So that is often called a tangent line. So along any x coordinate, so let's say this is the x coordinate 2, what would be the slope of the line at that point? So it's constantly changing for a parabola, but if we have any function, so this is just the power rule, of any function y is equal to x to a number n power, and I'll prove that maybe in the next video if I have time in this video. To any number n, its derivative, which can either be written as dy over dx, and that's not really a fraction, it's just a term of notation, or just y prime, which is signified by that. Both of those will, so it's just going to equal n times x to the n minus 1. So that is the power rule. So this is the power rule. Okay, so that's an extremely important part of derivatives since it covers most functions. Okay, so let's see. So what would the slope of the line be at this point? So let me see if I can try to approximate slope. So the slope of the line will equal, so actually let's take the derivative of this function of y is equal to x squared. N is equal to 2 because you can probably see. So now we can make it into, so it's 2 times x to the 2 minus 1, or just 2x. Okay, so let's plug in 2 for that, and now we have 2 times 2 is just equal to 4. Okay, so that slope is equal to 4. Pretty interesting. But let's try to do it for some other functions. Let's say we have the square root of x. So y is equal to the square root of x. Okay, so now let's just use the power rule. So as the square root of any number is just that number to the 1/2 power. And you can probably show that by squaring it. You get that, and it's just that number. Same with this, so I'm going to make a proof of that in a later video. But anyway, okay. So we can rewrite it as that. So now let's do it. So this works for any real number. So it's 1/2 times x to the negative 1/2. And what would that be? That would just be 1/2 times 1 divided by the square root of x, or just 1 divided by 2 times the square root of x. Okay, so that actually is pretty interesting, and I could prove that. Okay, So that's basically the power rule. And now I'm going to show you why it works. And we're going to get a bit better understanding of derivatives. Okay, so let's give ourselves a bit more room. And so here's the definition of the derivative. It uses limits, which you may or may not have learned yet. So they're pretty easy to learn. The limit, it's often done by like LIM. The limit as as often the variable x, or sometimes another variable, approaches a constant c, will equal for the function will equal f of c. But oftentimes that won't be a real number, so you just kind of get numbers closer and closer to c and approximate it. So that's kind of how you do it. So it's the limit. So this is the definition of the derivative. So it's the limit as h approaches 0 of the function trying to take the derivative of f of x plus, sorry, the pen's not working too well, f plus h, oh sorry, f of x plus h, and then, sorry, okay, so f of x plus h minus f of x and all that divided by h. So as you can probably see, we cannot just plug in h 0 for h, because then it would just be f of x minus f of x, which would be 0, and h divided by 0. So 0 over 0 is just undefined. That 0 over 0 is undefined. Okay. So now instead of getting numbers very closer and closer to h for every function, let's try to do this for f of x to the n. So we're going to be mainly focusing on this part. So we could rewrite as this as let's give ourselves a bit more room. Okay, there we go. I'm going to switch to a different color. So we could rewrite this as x plus h to the n minus x to the n divided by h. Okay, so now let us write the binomial theorem. You probably have learned this, but the binomial theorem states that a plus b to the n is equal to the sum of this series. This is in sigma notation, so don't worry if you have not learned it yet. It's going to be n, that's how many terms there are. R is equal to 0, and it's just going to be n factorial divided by this whole thing, which is r factorial times n minus r factorial. It's just going to be m minus r factorial. That's the whole thing. Hope I have room enough for this, times a to the n minus r times b to the r. Okay, that's probably not too neat, but anyway, let's try plugging in. Let's try getting a few terms of this. So first we start with x plus h. So first we can have because x we're doing a and h is b, so we have that the first one is, so let's get this constant for r equals 0. It's going to be 0 factorial, which is just 1, times n minus r. N minus 0 is just going to be n factorial. N factorial divided by n factorial is just going to be 1. Oh yes, and if you haven't learned this yet, a number k factorial is just going to be equal to k times k minus 1 times k minus 2 all the way down until it's k, well, all the way down until it's just k minus 1, which is just going to be 1. So it kind of goes down like that. So that's what a factorial is. And I'm going to do a proof of the binomial theorem in another video. So okay, so it's just going to be 1 times x to the n minus r. R is just 0, so it's going to be x to the n and times b to the r, which is r is just 0. So okay, so now we have x to the n. But that turns out, so that's the first term, cancels out with that. So now we can get rid of that, the second term, m factorial divided by r factorial minus times m minus r factorial. So it's going to be m minus 1 factorial times the factorial of 1. Let's do that. So it's just going to be 1. So it's just going to be 1. So okay, and 0 factorial is just equal to 1. And then it's going to be minus 1, so it's going to be m minus 1 factorial. So that's, any number k factorial minus k minus 1 factorial is just going to actually equal k, and let's hope that makes intuitive sense. So it's just going to be n times x, so it's going to be n minus 1 times h, and all the next terms are going to have a higher value of h. So let's divide all of them by h, so we can get rid of this in the denominator, and that's supposed to be an h, not an n. Sorry if I confused you, but and this term, all the others have an h, so now it's okay to plug in 0 for h since we changed the function a bit. Okay, so let's plug it in for this. And here we have this. So this actually works. So now we have n times x to the n minus 1, so that is a proof of the power rule for all positive integers. So I will probably make another video about this, or like about more proofs of the power rule for numbers, or for kind of obscure powers, like maybe x to the 8/9 or something. So or x to the irrational number instead of just positive integers. Okay, so thanks for watching, and please come back next time for more on derivatives. Thanks.